Hello and Assalamu alaikum everyone. My name is Arsalan Farooq and I teach math and physics. In this video, I will discuss some formulas of probability and also how to identify independent events of probability and mutually exclusive events of probability. So as far as independent events are concerned, independent events are those events where if one event has occurred, the occurrence of that one particular event does not affect the probability of the other event. So if one event has happened, then you find out the probability of the other event that remains unchanged. If that is the case, then such events are called independent events. Now, this is a symbolic notation of the probability of B given that A has occurred. So if you're finding out the probability of B given A and that is same as the probability of B, which it has not affected by the happening of A, then such an event is called an independent event. If you have two events which are independent events and you want to find out the probability of A intersection B, that is the probability of A and B occurring together, then you can just simply multiply the probability of A with probability of B. So for independent events, probability of A and B or probability of A intersection B is equal to probability of A multiplied by probability of B. For example, if you're throwing two dices and you are checking the score on both the two dices, the result of the first dice does not affect the probability of an event on the second dice. So obviously the score on two dice are two independent events. So if you're throwing two dice and you know that probability of getting a 6 on one dice is 1 by 6 and probability of getting an even on the other dice is 3 upon 6, which can be simplified as 1 upon 2. Now if I want to calculate the probability that the score on one dice is 6 and the score on the other dice is even, then I can just simply multiply these probabilities and I get the probability of A intersection B. For another example, if I have a box which has 5 red and 4 blue colored balls. So if I pick one ball and then I pick the second ball, the probability of the second ball would be affected by what color I choose on the first ball. If the first ball chosen is red, then the second red would be 4 upon 8. But if the first ball chosen is blue, then the probability of red is going to be 5 upon 8. So that means what color comes on the first ball affects the probability of the color on the second ball, which will not be the case if I would replace the first ball and then pick the second ball. Which means if I pick the ball and then I replace it and then I pick the ball again, then that means that the second ball's probability is not going to be affected by what color I choose as the first ball, because the total number of balls in the box will remain unchanged, and that is going to be an example of independent events. The other types of events are mutually exclusive events. Mutually exclusive events are those types of events which do not occur together. So if two events cannot occur together, then such events are called mutually exclusive events. And if such events cannot occur together and you can identify that the events are mutually exclusive, then the probability of A intersection B, that is probability of both occurring together, would be equal to 0. For example, if you throw a dice and if you check the number on the dice, what is the probability that it is odd and multiple of 4? So you know there is no such number which is odd as well as multiple of 4 together. So that means these are mutually exclusive events and the probability in this case is going to be 0. Similarly, on a particular day it rains and it also doesn't rain. So there is no possibility that's gonna happen both. So these two events are mutually exclusive events and the probability of their intersection is equal to 0. So we can represent the two events on a Venn diagram in sets, where one set represents possibilities of one event and the other represents the possibilities of the other event. So by looking at this diagram, you can sort of identify some certain formulas. Like if I want to find out the probability of A or B, or the probability of A union B, then that would be probability of A plus probability of B. But you would notice that when you do probability of A plus probability of B, then the intersection of these events are being added twice. So you have to subtract the probability of A intersection B. So this is a very universal formula that you can use in all situations, that probability of A or B is equal to probability of A plus probability of B minus probability of A intersection B. But you need to identify that if the events are known to be independent, then you can find probability of A and B, or A intersection B, by multiplying the probabilities of A and B together. And if they are mutually exclusive events, then this probability of A intersection B would be equal to 0. Mutually exclusive events means that there is no possibility that A and B would occur together. So this is going to be 0, and your probability of A or B for such cases will become probability of A plus probability of B only. Also, looking at this particular example, if you want to calculate the probability of neither A nor B, then if you get probability of A or B, you subtract it from 1 and you will get the outside probability of neither A nor B. Now let's have a look at an example. If you toss an unbiased coin, getting a head on one coin, if only one coin is tossed, it's going to be 1/2, because there are either it's going to be head or it's going to be tail. But if you throw two coins together, what is the probability that you are getting head on two coins? So the outcomes are head on both coins, head on one, tail on the other, tail on one, head on the other, or both tails. So probability of both head is going to be 1/4. That's the probability of heads on both coins. Now, if you want to check that these two events are independent or not, so you multiply probability of head with probability of head, which is giving you probability of A intersection B if independent, and which matches the probability of A and B. So that means these two events are independent. So if two events are independent, then probability of A intersection B must be equal to probability of A times probability of B. Similarly, if a regular biased dice is being tossed and I have to find the probability that the number is even, I can see that there are 3 out of 6 which are even numbers, so the probability is going to be 1/2. Or if I have to find the probability that the number is greater than 4, so I know that either 5 or 6 is greater than 4, so its probability is going to be 2/6. If I have to see it's even and greater than 4, then I can see that there's only one such number and its probability is going to be 1/6. If I want to check that the events are independent, I'll find the probability of E times probability of 4, which is coming out to be 1/6. That matches the probability of E and 4, which means that the events are independent. Let's take a look at another example. You have different colored balls which are also numbered. I have to find the probability that the ball is red, so there are 5 red balls, so the probability is going to be 5/10 or 1/2. If I have to find the probability that the ball is blue, there are 3 blue balls, so that probability is going to be 3/10. Then I have to find the probability that the ball is having an even number, so I'll see which balls have even numbers. So 2, 4, 6, 8 and 10 are even numbers, so there are 5 even numbers. The probability is going to be 5/10. Then I have to see if ball with even number and ball with blue color are independent events. So I can see that there are 2 balls with even number that are blue colored, so the probability of ball which are both even and blue colored are going to be 2/10. So if I look at the probability of intersection of 2 events, that's coming out to be 2/10, which is 1/5. But I've already found out the probability of even. and blue. If I multiply these probabilities, that does not come out to be equal to probability of E intersection B. So that means that the probability of E intersection B is not equal to probability of E times probability of B. Hence, these events are example of not independent events. Let's have a look at another example. I was given probability of A, probability of B. I had to find probability of A intersection B and probability of A union B if the two events are mutually exclusive. If they are mutually exclusive, probability of A intersection B would be equal to 0 and probability of A union B would be just simply probability of A plus probability of B. If I know that the events are independent, then probability of A intersection B would be equal to probability of A times probability of B. And once I get probability of A intersection B, probability of A union B would be equal to probability of A plus probability of B minus probability of A intersection B. And hence you'd be able to find out the probability of A union B. Guys, I hope you found this video useful. If it did help towards helping you to identify what are independent events, what are mutually exclusive events, and how to calculate probabilities of the intersection and union of such events. If it did help, I would really appreciate if you would give a thumbs up and also subscribe to my channel. Thank you.